Hi everyone. Hello everyone. Good afternoon. Very good afternoon all of you. Good afternoon guys. So all of you, hope you are all doing well. Lunch gets over for all of you or not? Everyone. Great. So here we'll be moving on to this next session of this quick revision of this highway, you can say, right? And we have started and we were continuing the discussions now. So no, we were discussing about this one, you can say, right, that highway quick revision series, right? So just within this week, mostly this highway quick revision gets over, you can say, all of you, right? So this highway quick revision series, you can say, okay. So all of you, welcome to Unacademy. Let's crack it, right? Everyone get ready to crack, all of you, right? Here these are GATE 2024 toppers from Unacademy, those who have secured AIR 1, and this is the prize you are having, all of you. That limited period offer is only available. Limited period offer is only available, you can say, right? So this is 9,999 rupees. At this 9,999 rupees, you can have your GATE 2025 preparation, you can say, right? And what is that? A referral code you have to use, right? RP Civil is the referral code you have to use, you can say, okay? And so if you are taking this plus subscription for this 9 months, it is at this 9,999. Iconic subscription if you are taking for 9 months, it will be at this 15,999, right? So don't miss this opportunity, everyone. So what is that? A referral code you have to use always. RP Civil is the referral code you have to use, okay? So this offer is valid only for a limited period of time, right? Don't miss this opportunity, everyone. So this Pratishta batch for this GATE, ESC and this PSUs 2025, it will be available at which one? This will be starting from this 13th July, right? So surveying will be started by Jespals or at 11:30 AM, right? Don't miss this, all of you. What is that? A referral code you have to use, right? RP Civil is the code you have to use, right? Shikar batch for this 2026 aspirants, right? Those who are aiming to write the GATE examination 2026, for those aspirants also, so this is given, you can say, right? So the same batch will be starting on the same day, 13th July only, right? Don't miss it, everyone. And what is that? Referral code you have to use, right? RP Civil is the only code you have to use, right? Now if you are taking iconic subscription, then you will be getting these books, right? The list of these books delivered to your home within 15 days of your subscription, you can say, okay? Now this is my profile, you can follow me, Twitch, and this is a referral code you have to use, right, when you are subscribing to any classes, right, any courses, right? Now coming to this, right, what is that we have discussed? If you just observe in the last class, right, which we had this class on this 8th July, na? So now we had this class on when? 8th July we had this class. And what are the topics we have discussed, if you just remember? So that a traffic flow model, right? Other models like which one? This Underwood model and this Underwood exponential model and this Greenberg logarithmic model we have done, na? So if you just remember. Now coming to this, right, this is signals also, that a phase diagram of this signal we have written, if we have drawn, and signal cycle length, what is that? Green time plus this, amber time plus this, red time, that is your cycle length, and optimum cycle length based on this Webster's formula we have seen, right? And in this, what is that L value and what is that capital Y value we have seen, if you just read up to this point only we have seen, right? Is that clear, everyone? So that 304 point optimum cycle length and what is the capital Y and all these things, you can say, that's it. Yes, now so these are the things we have seen, right? So this is your 304th point. Now we'll be discussing about this. The traffic signal will complete and then we'll enter into this traffic signal delay, okay? Right. So here this is your, which one you can say, that is your 305th point, right? 11 subjects out of 14 from YouTube. Is there any chance to achieve 600 plus score? Yeah, only thing is, if you are completed subjects perfectly, right, with full knowledge, then it is possible, right? But not all topics you have completed, and which one PYQs you have to solve, test series you have to attend, right? So that will be very important, you can say, right? If you are done your test series and this PYQs now, then there are chances, okay? Then there are chances, you can say, okay? Right. So we cannot give our number here, Mohit, right? You can. So regarding what, if you wanted to contact regarding me, you can just join my Telegram channel, ENGGGURUCIVIL, right? So it is a public channel. You can join this Telegram group and you can contact me there, right? Directly we cannot give the number here, right? Right. So now, so what is that? You can say, if you just observe that effective green time, right? So what is that effective green time? You can say effective green times, right? How can you get these effective green times if you just observe? So here already we know this y1, y2, y3, y4 na, yes or no? So effective green for this first phase g1 will be equal to, right? How can you get that? That is your small y1 by this capital Y. Capital Y we know, right? What is the capital Y? Sum of this ratios of this normal flows to the saturation flow, right? So that is what. So y1 by this capital Y into that C0 minus L, right? So like that. Similarly, right, what is that you are getting? That gi, ith phase, it will be equal to which one? This yi, small ii, divided by which one? This capital Y into that C0 minus, what is that you can say? That is your capital L, right? So now tell me, what is the meaning of this effective green time? First of all, if you just observe, what is the meaning of this effective green time? Effective green time is nothing but your, it is the actual portion of this cycle length, right? What is it you can say? It is the actual portion of cycle length. This is for which purpose? Tell me. It is the actual portion of this cycle length used for what? Tell me. Used for a running of vehicles, na? Used for this running or this moving of vehicles, na? Moving of these vehicles or this running of these vehicles, right? But here if you just observe, right, what is that you can say? After getting this effective green, right, what is the use? Whenever you are providing the signals, we will be providing like effective green time will provide, or actual green, actual amber and actual red will provide. Actual green, actual amber and this actual red will provide, you can say, yes, na? So here minimum amber time, right? Individual green, red and this amber times you are going to get, na? Yes or no? Minimum amber time, isn't it? So what is the purpose of this amber? If you remember, the purpose of amber is to cross the intersection, either to stop at the intersection, right? Suppose if you wanted to stop at the intersection, for stopping at the intersection, at a minimum how much distance you have to travel for stopping comfortably? So if you are traveling with velocity v and you have to come to this, which one? You have to stop at this place, right? You have to stop at this place, that v will be equal to 0, right? Now what is that? Yes, to stop the intersection and also to clear the intersection. First we will consider to stop at the intersection. If you wanted to stop at the intersection, right, what happens? Tell me how much it is required. If you just observe that a minimum amber time required to stop only, right? What is that? SSD divided by this speed, na? This is for which purpose? To stop only. But if you wanted to clear the intersection, right, how can you clear the intersection? We have to provide time only for stopping, or we have to provide time for crossing this intersection also? Crossing this intersection, clearing the intersection or crossing the intersection, both are same. So this is your width of the intersection or intersection road. Now when your vehicle crosses this intersection, then this is your length L, you can say. So what is it? SSD plus W plus this L, right? So what is that minimum amber time we have to go for? That minimum amber time will be equal to, what is that? SSD plus W plus L divided by which one? V. For which purpose? To stop, na? Oh, sorry, to cross the intersection, na? To cross or clear the intersection, right? Is it clear? Either it is to stop at intersection that much time, and to clear the intersection at which one we have to provide? To clear the intersection at which one we have to provide? Tell me. This one we have to provide, right? Like that. Is it clear? Right? Note this and tell me. Once it is not, tell me everyone. So this is a minimum amber time, right? Whichever the purpose you want, right? So for what purpose that amber time you wanted to provide, right? But which one is better? Tell me. Stopping purpose if you are providing the amber is better, or clearing purpose if you are providing the amber is better, right? Which one is better? Clearing purpose if you are providing the amber, that is better, no? So no. Clearing purpose if you are providing it, that is the best one or not? Yes or no? That is the best one, or that is better, you can say if you just right. Is it clear? Right. Now this and tell me everyone. Done all of you? Once it is done, I'll move to the next point then. Somebody respond. Okay, right, I'll move on to this, assuming that you're done. So now, so what is that effective green time, you can say if you just observe. So we have this, what is it we have? Effective green time will be equal to, effective green time for the ith phase is equal to, right, what is it you can say? Green time for this ith phase plus this amber time for this ith phase, right? This is the allocated phase time, na? Out of this, right, what happens that the startup last time for the ith phase minus this clearance last time for the ith phase are not utilized, right? So we have mentioned this one, right? Startup last time per phase, right? TSL, right? And this is your clearance last time, right? That is your TCL, right? So TSL and TCL are representing the startup last time and clearance last time, right? So here we know this value startup last time will be taken as 2 seconds. This clearance last time also already you have to decide on our own. Amber time we know, effective green we know. From that what you can calculate, if you just observe that actual green we can calculate, na? Yes, no? Amber time we know and actual green we know. Then after that, what is the cycle length, you can say? Cycle length is nothing but your actual green for that ith phase plus this actual amber for this ith phase plus this red. It is not all red, it is red for that ith phase, right? Cycle length we know. Just now we have calculated the green, we know that amber, then you will be getting that red, na? So finally which one are obtained? Green is obtained, red is obtained, and amber is obtained, and a cycle length is also obtained, na? Here everything is obtained, right? So then you can give these timings in that cycle. So give this timings in this signal, and you can get that, you can say if you just right, isn't it? Is it clear? So that is what we are having if you just observe, right? Isn't it? Now so here whenever you are having this, right, what happens? So that a normal flow whatever we have used on the critical lane, right? Normal flow present on the critical lane, right? That a normal flow present on the critical lane, whatever it is there, so that is used for which one? This design of your signal, right? Now after design of this signal, so whether this much flow is possible or not, we have to check, na? So it is better we should have this flow equal to this QI or more than this QI, tell me, because of the signal. Before designing the signal on the critical lane of any particular phase, let us say 900 vehicles per hour are moving. After designing the signal, it should be converted to this 700, or it should be converted to more than 900. It should be converted to more than 900 possibility, na? Yes, then only there is a use of signals. Otherwise, before signal itself, if it is allowing more flow, with the signal it is allowing less flow, is there any use of the signal? The signal is of waste of money, na? Isn't it? So what is that we need to do? We need to check the possible flow with the signal design. Okay, what is it we are going for? Possible flow or what? or capacity with what you can say, with the signal designed, with whatever the signal we have designed, how much is that flow possible you have to go for, right? Got it? So how much possible flow will be having, that is your QPI, right? What is that QPI you can say, that is your GI divided by this C naught, right? So means effective green for this ith phase divided by this cycle length. Effective green, how can you calculate? Actual green plus this amber, actual amber minus startup last time minus clearance last time, no? Yes or no? So effective green by this cycle length into what is that you can say, 3600 divided by this TH, right? Time headway, right? So you can also write it as what is that? So GI by this C naught into what is that you can say, SI. What is that SI? Saturation flow for this ith phase we have mentioned now here. This one, this denominator wala SI, the same SI. Now, so what is that possible flow you can say? That possible flow for this ith phase will be on single length. Excuse me. What is this? This effective green by this cycle length is called with which name to you can say? This is your effective green ratio, no? It is your effective green ratio, right? Effective green ratio into, right, what is it you can say? That is your saturation flow, okay? That is your saturation flow, right? Effective green ratio for this ith phase into saturation flow for this ith phase, right? Why for ith phase only? Because we want the possible flow for this ith phase only, and it should be greater than which one? This QI. It should be greater than which one? It should be greater than this QI, right? What is that QI you can say? QI is the normal flow for this ith phase, na? Isn't it? QI is the normal flow for this ith phase or not? Isn't it? Is it clear? Like that. Okay. So this is what we are having. You can see if we just write. No. Right. So now, so if you want that fellow, any person entering the intersection should clear the intersection. And when that fellow can clear the intersection, if you just observe intersection clearance time for the vehicle, right? What is the intersection clearance time for the vehicle? How much time is required? So SSD plus W plus L divided by this V, na? So intersection you can say that intersection clearance time for what? For a vehicle, na? So for a vehicle it is a required time, na? So what is that time required? If you just observe, that will be equal to SSD plus this W plus L divided by which one? This is V, okay? That is your intersection clearance time for a vehicle, right? Now similarly, right, what is that pedestrian crossing time for a vehicle? So pedestrian crossing time, tell me. Intersection clearance time for vehicle for pedestrian. Pedestrian crossing time, so that TP will be equal to which one? This width of this road divided by this velocity of this pedestrian, right? Like that, okay? Same total distance to be traveled. So here what is it? The pedestrian, how much distance this pedestrian has to travel? You can say this pedestrian has to travel a distance of this W for crossing, na? Isn't it? So this pedestrian has to walk for this much distance, and he has to move up to this point, you can say, right? Got it? Clear? Like that. So here intersection clearance time means for vehicle to clear the intersection, right? So how much distance it has to move? Obviously it has to come up to this point. So this is your L, and what is this one? This is your W, and what is this one? This is your vehicle moving, right? This is your way from here to here, right? What is that you can say? That is your SSD just right? So for vehicle to clear, this much time is required. For pedestrian to clear, this much time is required, right? As now, now whether this vehicle can clear the intersection or not with the signal provided, we have to check it now. How can we check it whether this vehicle can clear or not? Is now there is a time called as your intergreen. IG. So what is that intergreen IG? It is not Inspector General, it is IG, intergreen you can say, right? What is that intergreen? It is a time gap between any two adjacent greens. Okay, it is a time gap between what? Any two adjacent greens. Or you can also write it as the time. What is it? You can say this is a time available for crossing intersection. It is a time available for which one? The crossing the intersection, if you just observe, right? Is not? So here, how can you get this intergreen for any phase, ith phase, amber time for this ith phase, plus this all red time. All red means that a clearance lost time, na? All red is nothing but your which one? This is a clearance lost time, right? So this is a time required to clear the intersection, and this is a time available to clear the intersection, right? So for a vehicle to cross the intersection, right, what is that condition must be satisfied? Tell me. For a vehicle to cross the intersection, right, what is that time must be? What is the relation must be possible? Tell me. To cross the intersection, na? Son, this is your which one? This is 311 point. To cross the intersection, right? What to cross? For a vehicle to cross the intersection, na? For a vehicle to cross intersection, for a vehicle to cross that intersection, right? What is it you can say? That time available, okay? That time available should be lesser than or equal to which one? This is a time required, okay? अपने topper academy. Which topper academy? Which topper academy? I did not join in any topper academy. I was in here only, right? Okay, so previously I was working in 𝐂𝐸𝐴cademy, and here I am in Unacademy directly, right? There is no topper academy I have joined, right? Is not right? I did not join in any academy, okay, previously, right? Which topper academy? I did not join, na? So I think you are mistaken, right? Which faculty you are talking about? The listen, right? So what is the time available? You can say that time available is nothing but your intergreen, na? Intergreen should be greater than or equal to which one? This is a time required, right? What is the time required? You can say that is your SSD plus this W plus this L divided by which one? This is V, you can say, right? Isn't it? Right. Right. Which topper academy? There is no topper academy I have joined, right? You just check your facts. Listen. What's your name? I don't know. Right. So since 2020, okay, since 2020 May or April, I am in Unacademy only, okay? I am not anywhere else, right? Previously I was in 𝐂𝐸𝐴cademy, right? I did not join anywhere name called as topper academy, okay? Right. Which faculty you are talking about? The legend, right? So here, so this is the condition must be satisfied for which purpose? You can say, right? This is the condition must be satisfied for which purpose? You can say to cross the intersection, right? For vehicles to cross the intersection, or not? For vehicles to cross the intersection, you can say if you just right, is not right now. So this is what you are having if you just observe now. So if you are taking this as cycle length, so what is that a cycle length C0? What is that a cycle length C0? Cycle length C0 is equal to which one? This is GI plus this AI plus which one? This is RI, na? GI plus AI plus this RI you can say. And how can you write this? You can say, if you just observe GI plus this AI, that effective green, from this if you just wanted to write it, right, how can you write it from here? You can say that GI plus this AI, we can write it as which one? GI plus this AI will be equal to that small GI plus which one? That startup loss time plus this clearance loss time, like that you are having, right? GI plus AI will be equal to which one? Right, effective green time plus startup loss time plus this clearance loss time, right? So how can you rewrite this? Effective green time plus this startup loss time for this ith phase plus this clearance loss time for this ith phase, right? Plus what is that you are having? That is your ready time. Now if you just observe, this is the actual time allocated for which purpose? You can say for moving of these vehicles. And during this entire time, right, what happens? You can say during this entire one, right, what is it you can say? Right, during this entire one, right, what happens? You can say, if you just observe during this entire time, right, what is it? So this is during this entire time, right, this is your which one? Right, this is your which one? Vehicles will be stopped, right? So can we consider it as this C0 will be equal to that effective green time plus this effective red time for this ith phase? Or I is mentioned actually, right? Ri dash is mentioned, means right, effective red you can say, right? So this, what is that we can write it as? The cycle length C0 is equal to what is it? If you just observe, effective green time plus what? Effective green time plus which one? This effective red time you can say, right? So this is your effective red, right? Effective green means right, during which vehicles are allowed to move. Effective red means right, vehicles are allowed to move or vehicles are not moving, during which, right, it is the time during which vehicles are not moving, you can say, right? Got it? Right. Right. So this is what you are having, this cycle length and this signal design completely. Okay, right. Once it is done, tell me. Once it is done, tell me. We'll just try to move on to the next. Okay, so next one. (313), right? So what is this 313? If you just observe, right, this is delays, right? So delays, right, what is that delays? You can say that a basic delay model, if you consider. What is that basic delay model? You can say, what is that basic delay model? You can say, if you just observe. So whenever your vehicles are approaching, so whenever your vehicles are approaching this, right, what is it you can say, right, this is first vehicle will come first, right? After some time that a second vehicle will come, is not? After some time third vehicle will come, right? Like that, one after the other, right? Which vehicles will come, right? N vehicles will come now, one after the other, right? Which vehicles will come? N vehicles will come into picture, right? N vehicles will come into picture, if you just right, isn't it? No. So here, right. Now here, if you just consider it, what is that you can say? So here, this is your Q length, this is your Q length, and this is your time. Okay, so whenever your vehicles are approaching, right, whenever your vehicles are approaching, right, what is it you can say? This one, how will approach, right? First vehicle will come first, right? Then after that second vehicle will come, right? Next after that another vehicle will come, right? So this is what they are having, right? Is not? So this is what you are having, if you just observe, right? So let us consider, this is your which one? This arrival curve. This is your which one? This arrival curve. And what is this one, you can say, if you just observe it, that is your departure curve, you can say. That is your arrival curve, and this is your which one? This is a departure curve, if you just observe, right? Isn't it? Now here, what is that, you can say, this is your total cycle length from here to here, right? What is it, you can say, that is your total cycle length, optimum cycle length, you can say. And what is this one? This is your, so first vehicle comes here and arrive, and after this much time only it will move, right? So means how much time it will be waiting for, that is your ri dash na, that is your ri dash, you can say, pictures of, right? And what is this one? During this time, right, all vehicles will be in motion na, so gi, you can say, this one, right? So c naught will be equal to that ri dash plus this gi, right? Ri dash plus which one? This is gi, you can say, right? Isn't it? Now, so first vehicle, how much delay you will be having? That ri is the ri dash is the amount of this delay you are having, right? Last vehicle, right, how much delay you are having? That is your 0 is the delay you are having na. So the 0 is the delay you are having, you can say, right? Isn't it? Now, what is that average delay per vehicle? What is that average delay per vehicle you are getting? That di will be equal to ri dash divided by this 2, because it is following the linear model. So average means that average of this first and last, if you make average of all, you will be getting, you can say, is not right? So clear this one? No. So this is next one. Webster has modified this delay model. Webster's delay model. Webster's delay model, right? Webster has given the delay model. Okay, so what is that Webster has given the delay model, you can say, if you just observe. So this is the same q length only on the y-axis. Same q length only will be having, and on the x-axis, right, what is it you are having? This time you are having, right? Because why this Webster has modified this model, if you just observe it, because whenever they are moving, vehicles are moving from one intersection to other intersection, right, one after the other, they will not move practically. So when it was very olden days, traffic was very lesser, one after the other they will be moving, right? But now what happens, you can say, but what happens, you can say, but what happens, you can say, so we'll be considering that vehicles will be, right, vehicles will be moving from one intersection to this other intersection, right, which in which manner, right, together they will be moving, some vehicles will be moving together or not? Yes, they will be moving together, you can say, right? So that is how, right, it will occur, right? So here if you just observe at a particular time they are starting, okay? So this arrival, all some of these vehicles will arrive, and like that, after that, one after the other. So these same vehicles will depart at the same time. Now they will depart at the same time, right? And you will be having this. Okay. Now, so similarly here, so what is that we are considering? This dotted one. This is a total operation of this vehicle's movement, right? That is taking place over which one? This is cycle length C naught. This is over, this is C naught. And what is this one over which it is taking place, right? That is your Ri dash. So this is your which one? This is gi, you can say, right? So this is your departure curve, absolutely. Departure curve, right? This is your which one? This what is this curve, right? Arrival curve, you can say. Okay. Now, so here, what is that average delay per vehicle? So previously also it is average delay per vehicle only, right? You have to be careful for this ith phase, right? I is mentioned means for ith phase. So what is that average delay per vehicle, you can say? That average delay per vehicle, right? Di will be equal to C naught by 2 into, what is it? 1 minus this gi by this C naught whole square divided by what? 1 minus, what is it? We have to consider it. 1 minus this qi by this si we have to consider now. 1 minus this qi by this si we have to consider, right? Isn't it? 1 minus this qi by this si, right? You can say, right? So now in another manner, right, if you are converting that into this format, right, if you are converting every delay model graph into this one, right, what is it? You can say same, this is your cumulative number of vehicles versus time if you are taking cumulative number of vehicles versus time if you are taking, right? What is it? You can say, so this is how if you are converting the curve. This is how if you are converting the curve, you can say, right? What is that? You can say here this is a normal flow we are having, and where you are having this saturation flow, right? Here we are having this saturation flow you can have. So during this effective green time only the saturation flow is possible. No, obviously, yes. Now what is this we are having? You can say this one, right? What is that? You can say this is your ri dash, right? What is that ri dash? Effective, right? This is your which one? This is gi dash, right? What is that gi dash? You can say effective green, right? And what is this total time? You can say that is your cycle and the c naught, right? Okay, like that you are having, right? So then how can you get this di if you are converting that into this format? Area of this triangle. Where I have taken money? Tell me the legend. I don't understand. What's your logic? You are accusing me of taking money, right? Where I have taken money from you? No, na? So what is it? Area of this triangle, that shaded portion. Area of which one? This triangle. What is it? A triangle, you can say that is your shaded portion. Divided by which one? Number of vehicles arriving, right? So whatever the number of vehicles arrived, just tell. Okay, right? So this is how we'll be having this delays, right? So in the next class, so we'll be going for which one? This is the next topic, continuation of quick revision, right? Thank you, have a good day.